Hello everyone, a warm welcome to all of you to a new presentation. Today we'll explore the principle, working and applications of colorimetry. Colorimetry is a quantitative technique used to determine the concentration of colored compounds in a solution. It's based on the principle that the amount of light absorbed by a solution is directly proportional to the concentration of the absorbing substance. Let's see the fundamental principle of colorimetry, the Beer-Lambert's law. When a beam of light passes through a solution, following events occur. A part of incident light is reflected, a part of incident light is absorbed. Remaining incident light is transmitted. As per Beer's law, when monochromatic light passes through a colored solution, the amount of light absorbed is directly proportional to the concentration of solute. As per Lambert's law, when monochromatic light passes through a colored solution, the amount of light absorbed is directly proportional to the length or thickness of the solution. When combining Beer's law and Lambert's law, let's say that absorbance A is directly proportional to the concentration of the solute C and the thickness of the solution L. Let's write the equation like A is equal to KCl, where K is a constant known as absorption coefficient. As the path length L is the same and K is a constant, A absorbance and C concentration are highly correlated. We can find out the concentration of the test sample by comparing with that of a standard solution by using the following formula. Concentration of the test divided by concentration of the standard is equal to absorbance of the test divided by absorbance of the standard. Now let's see the instrumentation of colorimeter. First of all, the light source. The light source emits light across the entire visible spectrum ranging from 380 to 780 nanometer. A tungsten lamp is commonly used. Then the condensing lens, which give a parallel beam of light. A monochromator is used to produce monochromatic radiation, that is one wavelength band, from a polychromatic radiation, that is white light. It allows the required wavelength to pass through it. Prism, gelatin fibers, grating monochromators or interference filters can be used. Now the sample holder or cuvette, which contains sample solutions. It's usually made of transparent glass or quartz. Now the photodetector, which measures the light passing through the sample. Finally, the display unit, which shows the absorbance value or optical density, which help us determine concentration. Now let's see the working procedure of colorimeter. Step 1. Prepare colored solutions of the compounds using chemical reactions. Step 2. Calibration using standard solutions. For the calibration, prepare standard solutions with known concentrations, then measure the absorbance of each solution, then plot a graph of absorbance against concentration. Step 3. Filter the required wavelength of light and direct it towards the sample solution in the cuvette. Step 4. Read the absorbance that appear on the screen. Now let's apply the equation. Concentration of the test is equal to absorbance of test divided by absorbance of standard, which is multiplied with concentration of standard. Colorimetry has several important applications. In healthcare field, it is used to estimate the concentration of hemoglobin in blood, to analyze biochemical samples like urine, plasma and serum, then to determine the concentration of chemicals in blood and urine, to evaluate the efficacy of tooth whitening products, and to diagnose dermal and dental diseases. In research, it is used to analyze the concentration of chemicals, dyes, and substances in solutions, to perform tests or obtain data from samples, to study chemical kinetics, to detect impurities. In quality control, it is used to test water quality, to determine the concentrations of plant nutrients in the soil, to evaluate the color quality of food items, beverages, and ingredients, then to measure the quality of printing ink, to measure the optical properties of precious stones, and to measure the sun protection factor of skincare products. In industry, colorimetry can be applied to ensure that the color of paints, textiles, plastics, and packaging materials meets standards. It can be used to check the quality and consistency of colors in paints and fabrics. In conclusion, colorimetry is a simple and reliable method to find the concentration of a compound by measuring its color intensity. It follows the Beer-Lambert's law and is used in many fields like healthcare, environmental studies, and research. Now let's conclude this short session on colorimetry. Thank you all.